Hello, this is Mr. Martin. In this video we are going to start Chapter 9. We're going to be learning about right triangles. And before we can get into right triangles and all their properties and applications, I want to go through a review of radicals because we're going to be using radicals quite a bit in this unit, and it'll be helpful for us to review those radical computational skills. So if you have trouble with this unit, make sure you get some extra help. This should be stuff that you've done in Algebra 1, so it should come back pretty quick. Let's go ahead and get started. So let's take a look at this first set of computations here. We've got 3 squared. If you remember that little 2 up there, it means to multiply 3 by itself 2 times. So 3 times 3. So 3 squared is 9. So hopefully you remember this from algebra. And then 5 squared again would be 5 times 5. So that 5 squared would be 25. And then 11 squared. And then also, anytime you want to pause the video and kind of work ahead and see if you know how to do it, feel free to do that as well. So 11 squared then would be 11 times 11, so 11 squared is 121. Alright, now let's go the other way, the inverse operations. So inverse operations undo each other, like addition and subtraction, multiplication and division, squaring, raising it to the second, or square rooting. Those are inverse operations because they undo each other. So the square root of 9 is 3, because 3 times 3 is 9. So when I say the square root of 9, I'm looking for a number that I can multiply by itself. In this case 3, I can multiply 3 by itself to get 9. Therefore 3 is the square root of 9. The square root of 25 is 5. So what number can I multiply by itself to get 25? That would be 5. And then again, if we go one more, the square root of 121 is 11. Because 11 times 11 is 121. Okay, squaring a number is the inverse of taking the square root. So remember, when I say inverse, go ahead and write this down as well. These are operations that undo each other. Okay, so again, like addition, subtraction, multiplication, division, and then squaring and square rooting. Alright, so let's take a look at an example, and we're going to do these without a calculator. So most of the time when we're working on these problems, we do not want decimal answers. So keep that in mind as we go through. Alright, so for the first one, something else I'll mention a few times in the video is that you cannot multiply things inside a radical and things outside a radical. Okay, you can only multiply things that are both outside or if they're both inside. And I'll repeat that often as we go. So if I have 2 times the square root of 16, the square root of 16 is 4, so then this would be 2 times 4, which is equal to 8. Let's try part C. Again, anytime you want to pause the video. So I know that the square root of 9 is 3, so this is going to be 5 times 3, or 15. Now sometimes we'll have a negative in the front. Okay, that would just make our final answer negative. And then after the video you'll go back and do that one. So here's a couple of examples of simplifying. And then you're going to go back and finish the other 4 after the video. And then what I want you to do after you do that is make sure you go back and do the think about it. Okay, and then read that little statement there and decide what you think there. Now, sometimes it's not going to be a perfect square. because like the square root of 36, this is what we call a perfect square. Because the square root of 36 is equal to 6, there's a number. Sometimes it won't be a perfect square. For example, 54. Okay, 54 is not a perfect square. So in order to simplify it without using a calculator, what we do is we break it up into prime factorization, and we use a factor tree. Okay, so what we do is we just figure out numbers, any numbers that multiply to 54. So any factors of 54. So in this case we have 6 and 9. So this is some factors. So what we're trying to do is break this down into prime numbers. So let's write down, scroll back up here, and let's do a little review of prime numbers. Okay, so prime numbers, if you recall from algebra, are numbers where the only factors are 1 and that number. And the first prime number is 2, because the only way to get 2 by multiplying is 1 times 2. Alright, then we have 3. 4 is not a prime number because in addition to 1 times 4, we can do 2 times 2. Alright, and then 5 would be the next prime number. 6 would not be prime because 3 times 2 is also another way to get 6, or another way to say that is 2 and 3 are factors. And then we have 7. 9 doesn't work. That's a common mistake because 3 times 3 is 9. 10 doesn't work. Even numbers aren't going to work past 2 because they're all divisible by 2 as well. And then 11, 13, 17, 19, 23, and let's do one more, 29. So this is the first bunch of prime numbers. And there are certain mathematicians that are continually looking for prime numbers. If you have any interest in that, maybe Google largest prime number and see what you get. Alright, so basically what we're trying to do when we do prime factorization is we're trying to break down our number, in this case 54, into any of these numbers. Okay, so the first thing we do, we just pick any pair of factors. So 6 times 9 is 54. Then we check to see, are these two green highlighted numbers prime? They are not prime. So let's go ahead and let's break those down as well. So 6 is 2 times 3. Alright, and then we can see, oh, 2 and 3 are both prime. Those are both prime, so that's good. So we stop there. And 9 is 3 times 3, so we stop there. And if you notice, in the example here, these are all circled. And this is a good technique that I strongly recommend you do. When you get to the end of your branches, we call these branches because this is a factor tree, go ahead and circle them. Because now 54 we can see is going to be 2 times 3 times 3 times 3. So this is the prime factorization of 54. And if you want to check that on your calculator, you can. Just do 2 times 3 times 3 times 3, and you'll get 54. Alright, so I'm going to stop the video here. In the next video, we're going to look and see how we use prime factorization to help us simplify radical expressions. So make sure you get help if you need it, and we'll see you in the next video.